All right, so I'm going to finish number 15 from page 890, section 13.9. So we were going through and we were doing Lagrange multipliers, and we had set up our system of four equations up here at the top. And we had already gone through looking at, from equation 1, we got x equals 0. Went through and found 2 points from that, which were 0, negative 1, 1, and 0, 1, negative 1. Now, equation 1 also gave us lambda equals 1, so now we're going to address that and see what points we get from that. So for lambda equals 1, we have three different equations with lambda in it. We've already used equation 1 though, so our only options are to use equation 2 or 3. Equation 4 doesn't have lambda in it, so there's nothing we can do there with this right now. So I'll start with equation 2. And we take this lambda equals 1 and put it in our equation 2. Sorry, hopefully you have these in your notes from the last time, but I'll show you what equation 2 is. So now I'm going to have 2y equals, our lambda was 1, so 2y equals negative z. So we get 2y equals negative z. We'll solve for y equals negative z over 2. All right, so now we can take this and use it in another equation. We use 1 and 2, so I use this in 3. So in 3, so what was equation 3? I'll show you that one. Equation 3 is that 2z equals lambda times negative y. And now we have y and we have lambda. We're going to substitute both of those in there. So don't forget about the thing that you were starting with on the left. Lambda equals 1 holds for everything that we're doing here. So with that, we get 2z equals z over 2. So 2 times the number equals half the number. That means that number has to be 0, or you could go through and actually solve and you will get z equals 0 here. So now that z equals 0, we look at that here, that tells us y equals 0. So the only thing we're missing now is x. So where are we going to get? We've used equations 1, 2, and 3. So now we look at equation 4, and we use these two things in equation 4. And equation 4 was right there at the top of the page, x squared minus yz equals 1. So we know y and z are both 0, which is going to give us x squared equals 1. So we'll get x equals plus or minus 1. So using that in 4, we get x squared equals 1. X equals plus or minus 1. So now we have 2 more points. We have the point 1, 0, 0. And then we have the point negative 1, 0, 0. All right, so hopefully that's the same thing you all got when you tried it between now and the last video. So now what we're going to do is take these 4 points, substitute them into our function, and remember what our initial question was. We were looking for the points that were on that surface that are closest to the origin. So we were trying to minimize distance, which was our original function. So when we plug these points in, we're just looking for the smallest values. We're not looking for the largest values. So now our function was just f equals, it was a distance formula, but remember I said that we can use distance squared instead. So f of x, y, z was equal to x squared plus y squared plus z squared. And now substituting these points in, these 4 points, we get f of 0, negative 1, 1, f of 0, negative 1, 1. That's going to give us 0 squared plus 1 plus 1, so we're going to get 2 there. Then we do f of 0, 1, negative 1. It's going to give us the same thing. So f of 0, 1, negative 1 also gives us 2. And then f of 1, 0, 0 gives us 1. And f of negative 1, 0, 0 gives us 1. All right, so our minimum is 1. It occurs at the point 1, 0, 0 and negative 1, 0, 0. So those will be the answers to our question. So 1, 0, 0 and negative 1, 0, 0. And those will be the answers to number 15. All right, so I'm going to stop this video here. I just wanted to make sure we got that in for that problem, and then we'll continue 13.9 in our next lecture.